Okay, so before we actually complete a hypothesis test, take a look at what a whole process looks like for a claim. Let's revisit again the 5 steps. Defining parameter hypothesis, naming the test. The third step is checking requirements, which again for a proportion we have these same requirements that we've had in the past. The IRL. Is the sample independent? Does it come from a random process? And is it large enough, using again this idea of counting success and failures, because we're talking about proportion. So that's step 3 of a hypothesis test. After that, we collect sample data and then we measure a z-score. Specifically what we're doing, remember what a z-score is, how far above or below you are from the mean. What we're doing with a hypothesis test, we're going to be looking at the standard error. So we calculate the z-test statistic using this formula here, and this tells you how many standard errors, right? Again, because we're looking at sampling. Remember, we're using the basis of sampling distributions for a proportion, which are standard error, or the standard deviation of those sampling distributions is here, the square root of p times q divided by n. And so it's the number of standard errors. And once you have that value, right, given this situation here, you can see a simple calculation by substituting the values into it. We have this p-value, the claim, the p0, right, and the q is the complement of that. So if the person claims he's 85% shooter, right, the complement, or 1 minus p, is 15%. And so when he shot his 37 shots, made 37 out of 50, he was 2.178 standard errors below the claimed value, right? The claimed population parameter for John's shooting percentage. And so that would be the next piece. And then after that, once you have that value, right, what you do is you calculate the p-value. I'll find it here. The probability of actually that occurring if he was an 85% shooter is what we would then calculate the p-value, right? And then an important determination is, once we have that, is this idea of statistically significant. So in this case here, once we calculate the p-value, we run a hypothesis test. That's the heart of the hypothesis test, is obtaining this p-value, right? It's the probability of obtaining that observed value of our statistic, right? The evidence, that's what we're looking at here, right? This observed value of the statistic, what's the probability given, right, that the hypothesis, the null hypothesis, is true? That's this p-value, right? It's a conditional probability situation. So we'll say that the result is considered statistically significant, right, if the result is unlikely, meaning that if the sample data that we got is unlikely to occur, right, under the given situation, the claim, under the stated population parameter, right, in this case the proportion of 85%, right, we say then the data statistically significant, or results are statistically significant. Now, what do we know if it's unlikely, right? If an event's unlikely, we go back to the 5% rule in most cases. We often compare it to 0.05 or 5% because that's kind of the value we've been using for 95%. What's an unlikely value, right? More than 2 standard deviations, right? We call this our level of significance. Depending upon the test, we have different levels of significance, right? In medical situations, you would want different what we call alpha values. You've seen that before on confidence intervals, and these are connected to confidence intervals also. It's important, though, right, that we select alpha before performing the hypothesis test. You don't want to do it after, okay? And so we then end hypothesis tests before looking at a full example here with writing a conclusion. Once we have the results, we write a conclusion. We'll practice that, but our conclusion is going to be based off of our p-value is smaller than the level of significance, right? It will be based off of that. Is it smaller than our level of significance, smaller than or equal to, or greater than? And we use this language of reject the null hypothesis, right? or fail to reject. That's our language we're going to use. And since the p-value of whatever test you're doing is less than alpha, we reject, and then we say there's sufficient evidence to show that. And then we put the sentence in of the alternative hypothesis, whatever this is in these cases, right? And then, or there's not enough. And we'll revisit this idea, okay? And we'll say something statistically significant or not.